Hi.
Hi, Doran.
So, who here has used DBIx class in some form? Handful, about half it looks like. Okay.
Not as much as I'd like. That's why I'm here. I'm here to learn.
Let's see. Okay, so let's talk a little bit about DBI so everybody gets up to speed. Who's used DBI? Okay, almost everybody's used DBI.
DBI is?
DBI is, it's an abstraction layer for database connectivity. It essentially lets you can make calls to DBI to say, execute this SQL, and DBI talks to a driver underneath, and the driver talks to the actual database system. And what's nice about that is you can swap that driver out and plug another one in, and if everything works great, everything just works the same way as it did before. So in theory, it makes things pretty seamless if you're moving from like SQLite to MySQL or SQL Server. I mean, you still have the issue of compatibility of SQL statements because not every database system uses exactly the same. But if you
that is so hard to accomplish.
But it really does cut down on a lot of the nice. I remember when I first started doing stuff with Perl, and I was using Postgres. I think it was Postgres 95 back then. It's like 1997, something like that, and I was using the Postgres module, and it was shortly after that DBI came out. But if you were moving from, say, Postgres to MySQL, then you'd have to go through, and every single statement that dealt with the database, you'd have to swap that out with whatever the other database used. But with DBI, you just swap out the connection line, and now everything works just the same. So it makes it really easy to migrate code from one database to the other, in theory. But even if it doesn't work perfectly, it certainly makes it a lot easier than it would be otherwise. DBIx class makes things even cooler in the sense that not only do you not have to worry about the underlying database system, but now you don't even have to worry about SQL. It's an ORM class. What's an ORM? Well, I'm glad you asked. ORMs are object relational mappers. Essentially what this means is that every table in your database becomes an object or a class. And then you can reference the fields within a table as accessors of the object. You can set those values. And if you have relationships between tables, like say you have the example the DBIx class stuff uses is you have compact discs, CDs, you remember those? And you have artists. And so, you have a relationship where a compact disc has an artist. And so you should be able to say, for an artist, give me all their CDs. That kind of relationship becomes, so you have like a CD object, and you can call the artist object, and you get, you can call the artist method, and you get another object. You can call from the artist object, you can say, give me all the CDs that this artist has, and that returns a list of objects, that sort of thing. So this is not a novel thing just for Perl. There are other languages that have implemented something similar. Somebody over here has been doing Java, you did Java. Hibernate is one that's quite popular. It's an open source ORM for Java. The Python folks have SQL Alchemy, and Cake PHP purports to be a ORM. And then in Perl we have
language.
And then here we have DBIx class. Sometimes we just call it DBIc because we like shortening things.
That's too many characters.
A little bit of history. Well, very little history here. DBIc was founded by Matt Trout, affectionately known as MST. Yes. I say founded because if you look at the docs, there is a long list of contributors, and he just says, "Hey, I started this." Lots of people have helped. There's a website, and of course, some of the best documentation is already on your system if you haven't installed it's in the pods.
I read somewhere where Matt Trout was saying that he originally started kind of with an experiment, and then somebody started asking him questions about, now I'm using this in production, and his jaw dropped and he about fell over. You're using it what?
He kind of talked about that a little
Did he?
bit, because this was one of the modules that he was referencing in his lightning talk, and it was kind of that same type of thing. You're doing what? No, don't be doing that.
And now everybody's using it in
Yeah,
production.
now everybody's using it in production.
Yeah.
So what are the benefits of using DBIx class or any ORM for that matter? Well, for one thing, no more writing SQL, because now, DBIx class is talking to your database in SQL, but as a developer, you don't need to write SQL, because instead of saying select star from, this table of CDs, now you just say CDs arrow all, and all returns all the list of objects for the whole table. So it's a more programmatic way, a more developer friendly way of executing queries. This is one that I think a lot of more management types like, is they can not worry so much about junior developers knowing the SQL. They can just put them right to work and say, here are the tables, and now you can just go in and say artists, arrows, CDs, and you get what you need. You don't have to say, would I have to do a join or left join or right join? All that kind of stuff. Some of the caveats, well, no SQL. Trying to do really complex joins in DBIc is somewhat of a hair-pulling experience. But you don't have to do it the DBIc way. You can still back out and say, I want to do some SQL here, and go back to doing DBI.
Complex and/or statements get frustrating.
This is the one that I hear a lot, is because DBIx class leverages so many other CPAN modules to do its magic, that when you start it up, you get this. It takes a little bit of time to load all that stuff into memory. And so this is probably not as big of a deal as it used to be. And this kind of comes into what was just discussed at YAPC about CGI must die. Who's using applications where startup overhead is really that big of a deal, where every single request starts up, loads everything. Most web applications anyway. You incur that startup overhead when you start the server, and then everything just persists in memory and does its thing. Writing the result class code. This is essentially writing the code that wraps around each table. This can be tedious. It doesn't have to be. We'll talk about that in a minute, but it can be tedious. And if nothing else, it seems redundant, because you already wrote create table in SQL to create your table. And now it seems like you're doing almost the same thing when you write your result class code in DBIx class. Okay, so using DBIx class. Well, first you write your schema class that says, this is my schema, this is what it's called, these are some of the options we want to define for it. And then you write a result class for each table, and that says, these are the columns that are in the table, these are the relationships between this table and the other table, and this is how I want to refer to them, that sort of thing. So here's a really simple schema that I thought we'd play with in our presentation today. Really simple. I don't know. I've been to a couple of job interviews in the past 10, 12 years where they said, how would you write a blog? And I had one company that actually gave me an hour to see how far I would get in writing a blog system. And I used DBIx class, and it was pretty cool. And then I got to teach them all about separation of concerns, model view controller, because they weren't doing any of that. I didn't come back for a second interview. So. Anyway, so here's a really simplified entity relationship diagram. So we have a database with 3 tables in it. Blog post, which contains each post in your blog. In this, I figure we have a common author table that would contain information about authors of blog posts as well as comments, and then you have your comment table, and you can see that blog post is going to be related to comments. So every comment has a blog post ID and an author ID, and every blog post has an author ID. So let's look at how this is implemented. Well, first of all, our schema class. So I have a namespace that I called my blog. So I'm going to create this class called my blog schema, and it's a subclass of DBIx class schema. And then I just load namespaces. That's a method that's provided by DBIx class schema. That's all we really need in here. There's some other stuff you can put in there, but for this simple case, that's all we need. Okay, so let's look at the blog post table. Up here is our SQL to create the table. This is for Postgres for you people that are wondering what the heck a serial is. Serial is kind of an all-encompassing integer that auto-increments on insert. There's a sequence. It does it the right way. It's not like MySQL.
I would like to. No, I really can't.
Okay, so we have a post ID, which is essentially an auto-incrementing field that we give that we make that the primary key. We have a headline. It's a 100-character varchar. We have a timestamp because when you go to a blog, you want to see when did they actually say this, because since then everything's changed, that sort of thing. We have an author ID, and that references the author table. And then we have the body of the blog post, and that's just text. Okay, so here's our. I'm wondering if we can focus that a little better. Oh, there we go.
There you go. I don't have a squig anymore.
I thought it was my glasses.
I was like, it's just probably.
Yeah, let's rub your eyes.
I'm tired. I haven't driven anything. What's going on?
Okay, so in this is the result class for the blog post. So up here we say package, my blog schema result, blog post, and we're use base says we're using this. We're making this a subclass of DBIx class core. So this __ package stuff just says that they belong to this package that we declared up here. So the first thing we say is this is the name of the table. That tells DBIx class the name of the table in the underlying database to look at. And then here are the columns that we want associated. So we're just kind of reiterating these column names. The primary key, we use set primary key, it's post ID. And then here we're establishing relationships. So here this belongs to the author table. And here's the name of the class that defines the author table. And this is the field. I'm trying to remember if this is the field in our table. I think.
More table.
Yeah, I think this is in our table and not the remote table, even though it's the same on both sides. Then down here, this one's interesting. This says this is the relationship to the comments. So we know a blog post can have many comments. So this says has many. Comments is this big class, result comment, and so this is our name. Post ID is the linkage, because every comment that is related to the blog post is going to have the same post ID. Okay.
Is there an easy way to cache this setup as a configuration file or something like that, or do you just have to read it in and run it through the code essentially? Does that make sense?
Yes, no, but I'll show you a way that just gets rid of all this.
Okay.
I have to show you the hard way first, and then we'll.
You actually do a lot of writing instantiating this stuff, believe me.
Okay, so the author table, it's similar. We have I figure we have a username and an encrypted password, and first name, last name, email, and then I have down here: is this an author who can blog and not just comment? So that's a Boolean field. Another thing that Postgres can do.
You had me at the constraints, man.
So yeah, nothing really interesting. Everything's pretty similar here. We have a primary key, here we have that an author has many posts and an author has many comments. So that we set up the relationships between the other two tables. And then the comment table, kind of the same thing. Down here we say it belongs to an author and it belongs to a post. And that establishes essentially what our SQL does up here. Okay. So using it, now once we have this all this stuff set up, then you just use your schema class, my blog schema, and then you use the connect method that it inherits to connect to, basically it's a DBI connection string. It's a DSN. And that returns a schema object. And through the schema object, so here we're doing basically a select, but we're joining on the author table and we're saying, give me all the blog posts with the author with the username of Foz. Now what's cool is if you set the environment variable DBIx _ trace, all caps, and then you run this, you'll get to see the SQL that it actually generates as it runs. It's kind of cool. So this returns a list of posts, so basically a list of blog post objects. And then down here I have this little say there are 2 posts by this author. So what it's using lingua inflect to, if there's only one, it's going to say there is 1, and if there's 2, it's going to say there are 2. It's lingua inflect does all that funny stuff.
I'm sorry, what does the prefetch do?
The prefetch essentially does the join.
Oh, okay.
Because we were talking about this today at work about class DBI, which is a predecessor to DBIx class. One of the complaints that people had about that was essentially if you had this huge schema of lots and lots of tables, class DBI would load everything into memory at once. And that could be, it could be bad.
Swapping to this.
DBIx class is a little smarter than that. I don't know exactly what algorithm they use, but I know that the other objects that you can get to through relationships are not instantiated until you actually need them. So in this case, we're saying, go ahead and prefetch the author table so that we can do a join on it, so that we can say author.username here. So we don't have a lot of time to go into the nitty gritty, but I want to kind of give you a taste for what we can do.
But that does prefetch the entire author table.
That I don't know.
No, it doesn't.
It doesn't.
It doesn't. If from what little I saw under the hood, it actually grabs the core table that you're referencing, and then based off of that list, it goes out to the other table and then grabs that data set.
So it does a real join, not just a.
Yeah.
It's not a
And,
coded join.
and the thing is, it doesn't do it necessarily on the DB side. So if it determines that there's too many results, it will actually flop over and then compile it manually, or munge it manually.
Okay, so there's some intelligence behind the scenes.
It binds everything for you, so you don't have to worry about SQL injections too.
Yeah, that's another thing that's really nice. DBI is really nice because if you learn how to program for DBI, and you don't say select star where something is, and then you put in a variable.
You don't do that.
You actually use the bind variables where it correctly quotes things, and DBIx takes it one step further. You don't even have to worry about that. But anyway, this is the next step further. Once you've learned DBIx, now what you can do is use DBIx class schema loader, and this gives you 3 or 4 different things that you can do. One, you can create all your result classes by analyzing the database. So you can say, go out and look at this database, and assuming that you've got the table set up with the relationships between them and stuff with foreign keys and things like that, then it will create all that for you in the result class files. The other thing is, say you have a database schema that's changing a lot. It's in active development. You can actually write your application, and the documentation says don't do this in production, but if in development you can actually have it dynamically generate your schema files on the fly. So you can just say, go out and every time that I start up, I want to connect to this database and analyze the structure and create the schema classes right then. And so anytime you make a change to the database, you just restart the application and it goes through that again. But obviously, you get even more startup overhead doing that because there's that analysis. I haven't actually done this, but I understand that you can actually design your database in your schema files and then generate your SQL to create the database from within DBIx class. So,
With all the relationships and everything.
right.
Oh, cool.
And then you can do it based on whatever database backend you specify, which is kind of nice. Okay, so if you install the DBIx class schema loader module, you get this DBIx dump utility. And what's nice about this is you can say, okay, this is how you generate your schema files, your result class files. So let's
Live demo.
Ryan Foy says, never do this.
Here we go.
It's funny how many times I was said at that conference where they're like, okay, on to the live demo that you should never do.
Right. I heard that Damien Conway's live demos are not actually live. He just has it pretend like it's typing out,
When I saw him present at OSCON, he did all of his, it was the modern Perl, the changes that were in the newer versions and stuff, and then he also went into this regex stuff. And then he had something like that, which was doing his advanced regex mapping and everything, and it was kind of just, it just went through and played it.
Just pretending to type for him.
But it was like insane what he was doing with regex, and I'm just like, I understand it until you said the second thing you said after regex.
We got the first word.
I've got a look
I
ahead that does.
I wouldn't have known what you were doing anyways, but.
Okay. Oh, it's complaining. So let's go back to this. Okay, let's skip the inflate column. I'll talk about that in a minute. My blog, schema, and then we give it the DSN. Okay, so this, now if we go into the lib directory, you'll see there's a my blog folder,
Just created this.
and
And let's can we look at that?
it creates a schema file, and it's all documented too. So
So it does all the, where it gives you all the scaffolding and everything.
one nice thing about this is every single one of these files that's generated, it has a little section at the bottom. It says anything you put here after this line with the MD5 sum will be retained anytime you regenerate it. So if there's stuff that little things you want to tweak, you can just put them down there, and they'll be retained every time you regenerate. So that's your schema file, your schema class. And then if we go into schema result, you see here's the classes that were generated by looking at the database. So if we look at blog post, here's our name of our package. Here's our table. And yeah, it populates a lot of comments here that become your pod.
It's not almost kind of self-documenting on your database itself.
Yeah.
When you can just view your pod and see what where your relationships and stuff are and everything.
So yeah, there's a lot. This is a lot more verbose than what I had up there, because it's actually going through and pulling everything that it knows out of the database. So this data author ID is a foreign key.
It'll even detect cascades.
Oh, and then it even gives you the size restraints and the.
Yeah, if you have a cascade, like on delete or on update, it will actually record that here. It's
Yeah.
actually very smart about that.
And it gets it right every time.
Yeah, then you
Oh,
don't
there it
have
is,
to-
right there.
Oh, yeah, there's
On delete cascade.
Then you
On
don't have to
update. Yeah.
Worry about your syntax.
This is the way to go, because then your code is never out of sync with your SQL, assuming you not made changes to the SQL since the last
Right.
time.
Well, the point is you can detect changes in the SQL and then run this if there is any discrepancies.
So, so if you wanted to do a dynamic result class generation, so basically every time your application starts, it goes out, does the analysis of the underlying database, and creates dynamic result classes for you. All you need to do in your schema class is say, use base schema loader. And then when you do schema connect and you give it the DSN, the first thing it does is it goes out and does its analysis, and now you have result classes.
Does it just load that in memory then while you're running your application? So on each load, then it would just do that.
Right. Okay, so some of the components that you can add in here, in your schema class, in your result class, you can load these components. And there's a bunch of different ones, but the ones that I wanted to talk about are the inflate column. What these allow you to do is coerce. You can coerce data that's in your database into an object. For example, those of us that have used Perl a lot like datetime. We like the datetime object, the class that you can get from CPAN to deal with dates and times. It's really nice. It's one of the best ways of dealing with dates and times. So when you get data, when you store a date or a time or a date time in a database, a lot of times people have come up with really complex ways of taking that and parsing it and creating a datetime object for you. Well, DBIx does that for you automatically. All you have to do is, when you define your columns, you can have this component loaded up here, and then you can just say the type is datetime, and it will automatically do that. And that means that you can do things like in your code. You can have some object called, book, and we'll just assume that book is something that we've grabbed from the database. So you can say, say book, published date, year, and so because published date is an accessor for that field in the database, and then it's being coerced into a datetime object, you get these methods that datetime gives you, like year and month and all that kind of stuff. And then there's all the datetime math. So you can say, is this date more than 2 years since this date, and that sort of thing. All that stuff just comes with the territory.
So is inflate : datetime a plugin for
Yeah.
DBIx class? Okay.
Yeah, it comes with inflate column datetime and inflate column FS or file that basically gives you a coercion into path class. So if you have something in your database that's a string that is a path, you get a path class object
There's
out of
probably
it.
a bunch of other plugins on CPAN.
Yes. Here's some of them. Inflate column IP takes something, coerces it into a net address IP.
Does it support version 6?
Uh,
That address does.
I don't know.
We can look.
Probably.
I would imagine so. 'Cause
URI.
some of the stuff is-
Here's a data currency coercion, and it's really easy to roll your own. I mean, if you see if you want ways of dealing with certain data in the database, you can. It's easy to write your own inflator. So.
Bitwise.
And if you want to learn more,
Yeah, that's probably there.
this is where it's at. Is if you do a Perl doc on DBIx class manual doc map, you'll get kind of an index to all the documentation that comes with it. The intro kind of steps you through some really simple scenarios, and then the cookbook is a cookbook.
And they have a pretty good, I think the intro is the one that has a pretty good tutorial on walking through and getting it all set up.
The Catalyst tutorials also step through a lot of this stuff because most of the Catalyst apps out there leverage DBIx class. So they actually have, in fact, there's a Catalyst plugin called AutoCrud that does the dynamic schema stuff. So if you can point it at a database, and if you have this AutoCrud installed, you can say you can have your router say. I think by default, if you go to the website /AutoCrud, it will give you an Ajax-y, very nice Ajax-y interface to your database, and you can go and you can manipulate. You can add fields, add data, all that kind of stuff, and it's all based on DBIx class and so forth. So there's a website, there's a mailing list, there's an IRC channel, and there's a pretty active community behind it. I would love it if we could start using it where I work.
Yeah, it'd be awesome.
Yeah.
Just to
Also, if
answer
we could
your
use like 510 would be awesome. If we could use that, that'd be great.
I consider myself a force for change.
Hey, you're pushing. What's this
You
about
do
software
realize that
collections?
Ricardo made the comment, I asked him, how do you get admins to upgrade? And he said, well, first, you show them all the change docs so they can see all the security updates. Then you take them out for lunch, get them real drunk, conk them over the head, and then just do it for them.
That's good. Okay, any questions? All right, thank you.